That's not good.
Let me check another YouTube video and just see if I can.
Yeah, if you could check for me again, because I just checked it. I checked also, I don't hear it.
Yeah, I don't hear it. I just popped something open. There we go. It's working now.
It's working? Okay. Thank you. That's not good.
What's his YouTube name?
Okay, so yeah, we have it siliconed. It's siliconed around here. We have the antenna, and next thing we need to do is mount our antenna to some sort of bracketry. The Miguel antenna that I got from PhysTech.net comes with this bracket, which is really nice. So the bracket actually mounts like that, and then the other piece goes to the pole. So we're gonna put on our mounting bracket. I'm gonna disconnect our antenna if I can. I have to use some pliers. I'm kind of tight on that. Let me see if I need. I'm gonna need a hold back, so grab another plier. So if you try and take this apart and it starts spinning, you want to put a hole back inside of here, because you do not want the antenna from the internal side to spin. Okay, there we go. And now that comes loose. You can see our antenna. Alright, so now we're going to mount our antenna to the bracket. That's step one, and it comes with these 4 screws. And you can mount it pretty much right in the center, because then it lines up with the edge of that. And you don't go all the way down, you go about halfway, because it's compression fitting. It's compressing this a little bit, so somewhere right in between. And then find the happy spot for it. Halfway tightened down. I'm just going to go across each side until it's snug. It's not going anywhere. Right? So the next component is going to be, this is the antenna mount that I'm going to use. This is actually surprisingly a painter's pole for painting at long distances into the ceiling. It has an opening through the bottom, so water can pass right through. And this is about 4 feet long, and it has another 4-foot extension, which I really like. And at the end of the extension has this plastic tip, so it's not aluminum. And the pole itself is fiberglass, so it's non-conductive fiberglass. The only part that is aluminum that would conduct any kind of electricity is this pole, and it's pretty long. So you get an extra 8 feet and you can adjust the height for where your location is. And I think this will do a pretty good job for my application of how I want to mount to the side of the house. So what I'm hoping is that I can mount this as 5 mounting screws. I'll probably use maybe 4. I don't know, maybe I'll use 5 on each one. I put some reinforcing plastic so I don't crush the fiberglass, and I'll probably put some tape around these later just to give them a little bit more secureness and not so they won't slip. So this will be straight up in the air. I get about 8 feet, maybe 7 feet, something like that. And then at the end of the pole will be mounted the antenna. And the antenna is going to mount. Collapse this a little bit. The antenna is going to mount right to here. So I'll still be able to hit this and we'll be good to go. So in the kit it comes with these brackets, and the brackets mount like this. I guess they go this way. It doesn't matter. And it's going to pull against the aluminum and mount directly to the aluminum. Alright, then they give you a washer, a locking washer, and a nut. Just tighten that on. That's one. Washer, locking washer, nut. That's 2. And then I'm going to use one more of these. Washer, locking washer, nut. Washer, locking washer, nut. And just line these up so they fit nice. I'm going to hold that there for a second. I'm grabbing a specialty tool that I have. This is a pass-through socket set, and you can see there's, let's see, you can go straight through. So with these threads, I don't have to worry, it can go straight through. Sometimes you have to use a deep socket, you can use a crescent wrench, but if you find yourself a set of these, they're excellent for not having to worry. There we go. Not having to worry about your threads being too long and your sockets not being able to thread through. So you want to tighten these evenly. Start on one side, align your brackets. And these just have to be snug. You don't have to over tighten these and go crazy and crank on. You want it to be snug that they're not going to move, but you also want them to be evenly applied pressure. And that's not going anywhere. Perfect. Okay. Now we have a plastic tip to protect everything. We can still get access to the antenna cable. So when we apply our antenna, we can thread it right here. Just like that. Give it a little bit of a snug. Don't have to crank down on it. That's it. It's tight. It's not moving. And then the last step is a little bit controversial on deciding on mounting grounding. So this is currently not grounded because the pole is not grounded. It goes into fiberglass and the mounts are mounted to the plastic pole. So there's no grounding on this currently. But what I want to do, in my last one I put a lightning arrestor in between here. It's a small device that has a fuse built in, and then in between there is copper connecting in between the cable and the antenna. And it's a whole little device. I don't have one here, but it kind of looks like a socket set with a little mounting clamp. You can put one on. I'm trying something different. In my first video, for my first build, I put a lightning arrestor in, but it also reduces your dBi, so you get dBi loss for having another fitting. It's 8% that I want to try and avoid losing this time, and by doing that I'm trying to do a different way of grounding. So this type of grounding, I'm hoping this fits in here. This is a grounding clamp, and I'm hoping I can set up the grounding clamp to mount directly to the antenna. So right to the nut of the antenna. I am hoping that this will tighten up here, because if this is grounded, you know, this is a grounding point. It's not grounded internally, so if there's static, if some people claim that there's static that builds up, and the static can cause issues to your device internally, there is I would say evidence that that can happen. I don't believe it's going to happen in my application here that I'm using. So for me personally, I'm not doing this, but consult your local electrical authority on what to do. There's no real guidelines here from Helium other than people in the Helium community and their experience and the professionals that they've worked with, or that they are professionals themselves. So this is me experimenting. If you're worried about your device getting struck by lightning, put a arrestor in. If you're worried about your device having any issues with internal static electricity, put a lightning arrestor in. But in my case, I'm just mounting to the clamp. I didn't put this very tight, put it tight but not too tight, just so it doesn't crush the fitting here, because I want everything to stay secure. But yeah, that fit in there pretty perfect. So now we have grounding point. It's grounded here. It's grounded to this. This is grounded. And now what we need to do is run our 10 millimeter grounding wire to our grounding rod. This grounding rod, depending on the local code in your area, this one is 4 feet long. It has a spike tip end, and this is the end that you pound into the ground. So this is going to go into the ground, and I think it sticks out maybe about a foot out of the ground. So 3 feet will be in the ground, and this foot will be out. And then you mount here. So this is a grounding clamp that actually comes on the rod, which is actually surprising. So I have a fitting, electrical fitting here that I'll put the 10 millimeter gauge wire into and crimp that later once it's in the ground, and then tighten the screw to create a full ground. and then I will use this 10mm wire. I'll mount one inside of here. I don't know if you can see this. Take this out of the way. But there's a tightening screw here, and you strip a piece of wire, the 10mm wire, and thread it in here and tighten. I'll do that for you now so you can see. So I'll take one of the ends. This is solid core wire, by the way. Don't use threaded wire. You want to use solid core for grounding. It's a little bit harder to bend, but it is what is required. So I'm just going to take this. I have my strippers, wire strippers. Find 10mm, and then strip off maybe, I don't know, let's see, maybe a 1/2 inch, 3/4 inch, something like that. Expose the bare wire, and then the bare wire will go right through here, and tighten down on the 1/2 inch ground. Now the antenna is completely grounded, and this wire would run down the house and mount to the end of our grounding rod that is grounded into the ground. I don't recommend putting any grounding rod to your plumbing system because you don't know how it runs out of the house. It may look like it's going copper out of the house, but it could transition to PEX or some sort of PVC piping, some sort of underground piping, poly tubing that will not ground your electrical system. I know a lot of electricians try to steal a ground from the plumbing system. In most areas that's not legal, and it can cause issues because you could have a water filter in between, and the water filter could be made of plastic and it's not actually grounding to your house or grounding to the ground. So it would be a false ground, and you don't want that. Always install your own ground. Find an area that you're absolutely positive is a ground. And if this is going to be directly to your antenna and on your roof, you're going to want something that's not going to ground into your house, because if it gets struck by lightning, you could damage components in your home and things that you care about. So having an independent grounding system is the best option. You want your own ground rod for this device, for this antenna that's going to be on the roof, and that way it doesn't affect anything else in your home, and you're positive you have a real ground and not a false ground. So be do your due diligence and make sure that you're getting proper grounding. Buy a grounding rod, they're very cheap, they're worth the money, and then get it set up. So now we have our antenna mounted, and I'm going to disconnect this for a moment, and we have our ground and our grounding clamp to the antenna. You can put an inline one if you're worried about static. That's the lightning arrestor. I don't have one in this build. I'm just showing an optional build. You don't have to do it this way, but this is the way I'm doing it this time. I plan on mounting the enclosure to the box, to here. So in some way I'm going to strap plastic or use the mounting support brackets that they give me to the pole. Hopefully I can mount it to the pole, and then it's all in one spot and everything's grounded and I can access it pretty easily. The last thing that you'll need is a very long or short, depending on where your Ethernet is coming from. This is a 50-foot run, and if you want, you can get different sizes. You can cut them down your own and create your own lengths. That's what this tool is here for. It's a Klein RJ45 wire cutter and crimper to create a new crimped end. So you can make your own sizes. I've done that a bunch, and it works out really well. This would take place of this yellow wire because it's very short. It's only 3 foot maybe. But you can use this just the same. Either you have a pass-through that passes through, or like this one here, you can take this off, the cap. You pass through here. You remove the O-ring. You pass through the full fitting. It's a little bit. So the RJ45 goes through, and now you can plug this in. And now you can thread this in. Put the rubber washer in, and thread in your compression. You don't need any Teflon tape on here, remember. This is the seal, no Teflon. Tighten this up. And now it creates a pretty much watertight seal on the bottom. You can see the gasket is smushed around the antenna wire, and that is sealed. That's no water's going in through there. And you have your cap if you need it. And then this is our temp probe that we'll be sending through in a minute. So this will run down to your PoE injector, wherever that is, and your PoE injector will send power from your router or your switch to the unit to power the unit, power your fans, and start allowing you to mine helium. Yeah, so that's about it. And then you connect your antenna cable, and your grounding, and you're done. In another video, maybe I'll put together how I mounted this and show you how that went. But I wanted to get through some of the basics and tips about sealing around the air vents with silicone and making sure there's no bubbles. Even though there's a gasket and O-ring that's sealing this, it's preventative maintenance to put extra silicone around to make sure no water gets in. Make sure that you understand how grounding works, understand the grounding clamps, how to tighten, how to loosen your fittings, showing you different options for extending and getting length, because a few feet can mean the whole difference in getting further range for your signal and providing better coverage just by extending the pole, a few more feet. So if you have the option and you have the availability to add a pole like this, I've seen other ones. This is kind of my test impromptu trying something different design, and I hope this will give me the range and height that I'm looking for. The building I'm working on is only about a one and a half story building, but it's at a very high altitude, so that gives me an advantage. So I only need a few more feet that will give me a better signal across the area that I'm trying to get. So we got grounding, we have our antenna and our antenna mounts, everything's enclosed and sealed. We have our Ethernet and PoE, power over Ethernet, closure, grounding rod, and extension rod. And that's it. So I hope this was helpful. If you have any questions, post them in the comments and I can try and answer them for you. And if you would like any other videos, let me know and I'll put something together. But that's it for today. Thanks everyone. Till next time.